Uh-oh. Gotta fix this now. I forgot to stop recording. I'm recording the whole time, right? But that's okay because I can just start it again, and then I'll just cut the other one short. All right, we're back. It is COMP1073, and we are the winter 2017 semester, week 8, part 2 of our broadcast. We finished talking about assignment 3 in the last video, as well as we also starting to talk about objects, object-oriented programming, and using built-in objects like the date object. And here are some examples of the date object. We also went up on why is it so big? It's crazy big. I don't understand. We went up on W3 schools, and there's some good reference there, some good material there that you can always go to see some of that stuff outlined. Notice that you can create a date object based on a string that you kind of send in there. You can also create a date object with a date and time set according, to the year, month, day, and so on. And there's some examples of how to do that. So here's an example of Independence Day, I guess for the States, 1776. You can pass those values in, right? So today is a new date. And then after creating the new date, we can, kind of use these functions, the methods that are built into the date, right? In order for us to access these methods, right? So we call them. And we've kind of given an example of how to do that. So our example here is current date is equal to this new date. We can get the date with current date, get date, gets the current date itself, right? That's the date, the day of the month. That's what this is. And we can also get day and get month to generate the actual day. And here's an example of an if-else statement. Question for you guys. Do you think this is a great use of if-else? No. Well, I mean, it's okay. It's just that it's far better to do something totally different, right? In ECMAScript 2015, remember we're also talking about the latest version of JavaScript. We can't leave that behind, right, as we're talking. So if I go, can I use, if you go to caniuse.com, right, caniuse.com tells us some of our features. So if I put in enumerations, right, can I use enumerations in JavaScript, right? One day when this thing refreshes. So enumerations, there we go. So, you can see that web and MIDI API is there, but there really isn't an enum, right? There is no enum in JavaScript. How about class? The idea of class, class lists. There's also ES classes. Absolutely. We're going to talk about classes and objects. Get elements by class name. All those kinds of things are something that I can use. But the idea of an enumeration, right, is not really there. We do have another structure we can use. We're going to talk about that in a bit. All right, so you could have used also a switch case here, where you're switching the current day. So switch current day, case Sunday, or case 0, weekday is equal to Sunday, right? And then you can stitch together your date like that, okay? You can also, here's an example of where we're using a months array of months, right? January, February, March, and so on, right? And what you can say is current month, and this is why they start with 0. There's a reason why they use 0, right? They use 0 so that way if you go months today.getMonth, that would be the index of the months array, right? So you can get the month of whatever the month is today. Does everyone understand that? Okay. Let me do this example. So again, I'm just going to grab this months array. Let's make the months array for us. All right, so I'm going to go over here. And this is nice, but let's just get rid of it all for now. So today's date, there we are. And we're going to say, we're going to let months, right, our months equal to an array of months. We're going to say January, and then February, and then March, then April, May, June, July, August. Bear with me while I type this all out. I could have copied and pasted, but I want to keep up with you. August, September, October, November, and December. Okay, cool. And I can end it off with a semicolon. Okay, so now that I have this months array, notice that it's an array of type string. A string array is what it is, right? Because I've put strings in it. A bunch of strings from January to December. Okay, so this string here, this first one, what index is it? 0, right? It's index-based counting. So 0, 1, 2, 3, and so on. So now, if I want to say something like, let current month equal to today, right? Dot, right? Now, how would I do this, right? I want to get my current month, right? Well, I wouldn't do it today. I would say months, right? And then today dot, oops, today dot get month, right? Today dot get month is going to be a number between 0 and 12 and 11, right? 0 January, 11 December, right? And I can say something like this: console log, just to show you that current month. I go back, and if I show you what that looks like on the browser, then I can see that the current month is March. And how did I get that? Sorry, I'll go back to that code so you can see it. I made an array of months, string array of months. I let my current month equal to the value of the array, one of the strings in the array that equals the number that I'm going to get back from getMonth method. And the getMonth method is going to return a number from 0 to 11. And I'm going to plug that number into this as an index, and it's going to return the month. Okay. Well, if I can do that, I can also do it for days, right? So I can say something like, let day equal to an array of days, right? Where I start with Sunday. Let's see if it's correct if I'm starting with Sunday or if I'm starting with Monday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Is it like this? And if I do the same thing, can I do something like this? Let current day equal to day dot get day. Is that the same? And then if I console.log current day, right, will I get the same thing? Will I get today being Wednesday? Or will it be something else? Let's see. Wednesday, right? You can see how I can build up my date, right? So Wednesday, March, and the dates. So if I want to build up my whole date, I would do it like this, right? So I'll put these together, right? And I could do a more formatted month. This is all like manually. I can do something like console log, right? So current day plus space plus current month, right? Plus comma, space, and then the date, right? So I'll say today dot get date. That'll be the date of today's date, right? Let's see, maybe if I can add a plus in there, that'd be good. Right? Plus space. I don't know if no, let me see if this is correct. No, March 20th, 2017. Yeah, I guess I can put in like just the date afterwards. So space plus day dot get full year. And let me just open that up so you can see it. Let's see how that looks, and if it's accurate, we should get kind of the full date that I want. Wednesday, March 8th, maybe the comma should be on the 8th. So Wednesday, March 8th, comma, 2017, right? So how did I do that again? Remember, you have two arrays, months and day, and then you're getting using the index of the date that you're getting from the built-in function, get month, from the date class, and get day from the date class, and you're returning the number between 0 and 12, or 0, 11, and this one is between 0 and 30, right? And you're going to get these two values. You're going to index. I'm sorry, this is between 0 and 6, and you're going to access these arrays and use these as whatever you're getting as the index to access the value of the member that's inside the array, to get the element of the array that matches the index. There we go. Okay. Kind of a protracted example there again, but just to make sure it's clear. So Wednesday, March 8th, 2017. Now this is the time that's local, and if I want to serve up the time that's local to the other person, let's say, for example, if they're looking at the time and they're in China or in India right now, it's going to be a different time and a different day, actually, than we are today, yeah? Like right now, isn't it like afternoon or still early morning over there, right? In India, what is it? I don't even know. And same thing in China. Maybe China is another day too, or the next day in China, right? So if that's true, how do I give them the current date, whatever they're at? And you can use the other functions to do that, right? Because it calculates based on who's looking at it and where their location is. You can have you can populate the local date. Okay. Yeah.
Wasn't this like local to the machine anyway?
This?
I believe it takes the date from the machine anyway.
It does. It takes it from the server. Right? What's my server right now? My machine, because I'm using that. Yeah, so it takes from the server. So if I put this online right now, right, it'll still show the current date, that date, whatever it is, depending on where my server is located. If my server is in Canada, right, and in the east, it's going to be this date. If my server's in the west, it's going to show a different date altogether, wherever my server is, right? Unless I specify a specific date time, like a time zone, right, which I can do. So dates and times are one things we can get, and we can use them for other things. Okay, how about numbers? So again, you can use the number, right? So here's some number functions. To precision, whatever the decimal is, converts a number to a string with a number of decimal places specified by decimals. This is really useful when it comes to, kind of taking a string and adding a number of precision or a number of decimals to increase the precision of the number, right? To fixed converts a number to a string using the number of decimal places specified by decimals. Number to string, right? Converts a number to string. Converts a number to string. All of these do the same thing, but these add more detail so you can have, so your strings are more formatted. That's what this thing does. Okay, here's some example of that. So you can say to fixed. This is what it says, the most useful number class method, right? All right, well, let's try that out. So if I go here and I have a big number, So let's say, we'll do another example here. So let my number is equal to, we'll make a almost like pi, 3.141559786. I don't know, 7826, something like that. Anyways, so you know, if this is, let's say this is something like pi. Here's my number. I want to kind of show this out. So I want to say console log, right? And if I go to fixed, now if I want to do the number, if I want to do number dot to fixed, right? Well, hold on a second. It says to fixed, capital F, right? How come on my and here it says fraction digits, and then the number, right? Number of digits after the decimal point must be in the number range between 0 and 20. So I want to say to fixed, and I want to go with something like, I don't know, let's say like 4 decimal places, okay? And instead of number to fixed, we want to say my number to fixed, sorry. My number to fixed up. Okay. Let's see what this returns. So it should return 1415, right? Or should it be 16? That's pretty good, right? So you can actually limit the numbers and it rounds it right to the nearest decimal. That's a pretty useful function. If I just converted this to string, so instead of to fixed, I'll do the same thing, but we'll convert it to string. To string. And I won't pass 4 in there because it doesn't do that. To string is the base. It just passes it in, right? So if I go to here, there it is, the whole number, right? Now, what does it mean when it says base? If I go back to here, it says locale string converts the number to a string formatted with local numeric formatting conventions. All right, let's try that. So 3.14159, let's make it bigger, like a bigger number. So instead of 3.141597826, whatever it is, let's make it 10,000, right? 10,003. First of all, is this number possible? Can I represent this number? All right, be careful, because the bigger the number is, the more digits of precision it has. Computers can only do so much, right? So this is what it does. It converts it to this, right? And if I take this and make it so that it's locale number string, the locale string, right? And it's this, right? It has a comma in the right place. Again, this is very useful for number calculations, representing numbers properly in a form, all that kind of stuff. That's what the code is. Again, nothing too complex here, all right? Max value, min value, not a number. This is really important, not a number. You can check to see if not a number, right? Negative infinity, positive infinity, these are really important too, because when it comes to math calculations, these little built-in values are really important. And the math class themselves is actually really, really super important, right? Math, you can definitely do this and create a new math object, right? But it has a lot of built-in functions like square root, pow, ABS for absolute, and so on. And if you don't notice here, these are all the built-in functions of math. I'm not going to go through all these, but you can see that there's a lot of functions you can do to make your own calculations very accurately, actually, right? So again, arcsine or arctangent, cosine, you know, arc cos, right, or inverse cos, whatever, however you want to say it, same thing, right? And so on. There's a bunch of different functions that are built into math. One of the ones I like to use a lot is random, right? Random numbers. So I want to get a random number between 1 and 100, right? And I want to play the guessing game with you, all right? Let's see how this works, right? So how do I get a random number? So if you look at, again, if I want to set up a random, it's very simple. It's a static function. So I'm going to go down here now again. So again, this is all, here's some date examples. So date class examples. That's what these are. And down here, these are number examples. So number examples, where you convert a number to string. And these ones are math examples. And the one I want to use the most is this idea of this random number. Let's say I have a die. Here we go. Let my die is equal to math.random, right? Math.random sets up a number between 0 and 1, okay? So 0 is a decimal that you're going to get back from 0 to all the way to 1. It's an infinite number of points, right? Okay, cool. So whatever the number is between 0 and 1. I want to multiply this by 6, right? And I want to get something called the floor of this, math.floor. Here's something that's interesting, right? And then add 1 to it. What am I going to get? Math.floor, by the way, is a round down. That's what it is, right? Math.ceiling is a round up, right? So math.floor, I want to take the random number between 0 and 1, so some point value, multiply it by 6, and then add 1 to it, okay? And then what I want to do is I want to do a console log of the die. What's the die? So it's going to be a number between 1 and 6. Let's see. If I go back to here and notice it's 6. Okay, refresh. Should get a different number every time. 6. Oh man, what happened? 5. There we go. 5. 4. Right? 6. 4. 4. 3. Right? Different numbers. All right, what are the chances? Probability. I'm talking about math again. Probability. What are the chances of me rolling a 1, 2, 3, 4, 5, 6? What are the chances? Probability theory. Anyone remember? You guys ever do math? 1 and 6. How about for 2? 1 and 6. 3, 1 and 6. So it's a flat line. Everyone has equal chances, right? You can get the same number. There's no. It's not because you've rolled 15, 60s that you can't get another 15 6s if you want. If it's possible, it's a low chance, but you can get it. But how about when you add two numbers together? Then you get a bell curve, right? So if I get, instead of this 3, if I want to add two numbers together, like for example, let's make this die 1, right? And let's do the same thing. And we'll get die 2. Here we go, second die. Apply die 1 and die 2, right? Same thing. We're getting a number between 1 and 6 for both of them. Here's die 2. And you know what? The sum, or let's say dice, is equal to die 1 plus die 2. There we go. That's like a set of dice. These are like 2 6-sided dice for the simulating. Okay? That means I'll get a number between 2 and 12, right? Let's try this out. I get 1 and 2. Oh, I better print it out. How about that? Console log. By the way, once you have random numbers like this, 4 and 4 is 8. If I refresh, 1 and 5 is 6. 5 and 2 is 7. What's the most common number, probability-wise, with 2 dice? 7. Actually, 6, 7, and 8 are the most common numbers. 6, 7, and 8 when you roll 2 dice, right? Where 7 being the most common. And the least common are, probability-wise, 2 and 12, right? Which is less chances of getting those in the combinations that you get from a combinations and permutations perspective. Ooh, there's the math for today. So you notice if I roll these dice, I keep on doing that. You can see how they add together. 5 and 5 is 10. 6 and 3 is 9. And you'll keep doing that over and over again. Now, the reason why it's giving me these values, integers, it looks like integers, is because I've rounded to the nearest integer, right? I've rounded down to the nearest integer by doing math.floor. That's what this does, right? Returns the greatest number less than or equal to its numeric argument, right? So an example would be whatever the number is, it's a solid number, an integer value, a whole number. And if I use ceiling, here's two. There's math.floor and math.ceil, right? Returns the smallest number greater than or equal to, right? I like using math.floor. Thank you very much. That's the one that you would use for randomness. So this is math. I'm using math examples to calculate stuff together. How about if I want to calculate the distance between 2 points, right? I can make a more complicated example. I can have, here's a more complicated example, okay? So sorry, forgive me. I don't mean to make you crazy, but let's say x1 is 10, right? And let x2 be also 10, or y1 is equal to 10, and let x2 be equal to 20, and let y2, these are actually good values, is equal to 20. So from 10, 10 on a graph to 20, 20, x and y coordinates, right? I want to find the distance between these two coordinates, right? x1, y1, x2 to x2, y2. Well, the answer to it would be the distance is equal to math.square root, right, of math.power of x2 minus x1, right? x2 minus x1 to the power of 2 plus math.power. Notice I'm using order of operations. Y2 minus y1, and then to the power of 2, right? Oof. Right, there you go. Compound statement with math, right? Some good examples here. So what's the distance? And if I want to print that out, console.log, distance. If I go back to see what it is, you can see that the distance is 14.142135.6, whatever, of approximately 14 units. 14.1 units. Does that make sense? I'm using Pythagorean theorem, right? A squared plus B squared is equal to C squared. Right? This is or Euclidean distance. That's another way of looking at it. By the way, these formulas I've just shown you, Euclidean distance or Pythagorean, using Pythagorean theorem or whatever, and the random number generator are the two most common ways of making games today. Two-dimensional games. If I have some random number, I have random things to happen. And if I want to find the distance between 2 points, if things are colliding, the closer things get, I can calculate the distance between two objects and say if they're within a certain distance, there's a collision. If there's a collision, I can take away points or add points, whatever I'm going to do, right? So really common calculations here we make. Questions around this? All I'm doing is I'm using built-in classes here, right? I'm using the built-in date class, the built-in number class to convert to a formatted string, and then the built-in math functions, and I'm using a few of them here, right, to give you a value, the distance between 2 points. That's what this is. Distance between 2 points. That's what I'm calculating here. Or this is the first point. Actually, I'll put this down here for you guys. That's what this is. Calculate the distance between 2 points. And this is first point. And this is second point. Right? All right, that's pretty cool. Pretty academic stuff. Nothing too crazy, right? Again, I would have you guys understand this. You don't have to memorize it, of course, but this is a really good reference card for stuff you can do with math. And if you can think about it in math, it can mostly be done in JavaScript for the most part. And there's some other things here. These are properties for E, as an example, Euler's constant, or Euler's constant, if you will. Pi, that's a really good one to use. Square root of 2. Sometimes we use this again. The square root of 1/2, instead of calculating the square root of 1/2 is a property. Because these two calculations are very common, right? So we don't have to use them. We don't have to calculate it first because it's too slow to calculate it. We might as well just use them as store them and use them as a property. Common calculations. And they give you some examples here of math.pi multiplied by math.power to get radius and so on. All right, now this is the difficult part, so please watch carefully. And we're going to do this for the next hour, right? So custom JavaScript objects. We've been using objects that have been existing for a while. They're part of the JavaScript library. That's what we've been doing so far. And I want to use objects that are my own objects. How do I do that? Well, there's two ways. There's something called constructor notation. This is the constructor notation. So I can say var object name is equal to new using the new keyword, whatever the object is. That's one way of doing it. The other one is my var object name is equal to open curly brace, close curly brace. That defines two objects. Now these objects, do they have a blueprint? Not really. Yes and no is the answer. I'm gonna for this class, for the purposes of this class, I want to say for you, no, they don't. There's no blueprint. They're just empty objects. I want you to think about them as empty containers. That's all they are. Okay. So again, this is constructor notation. This is literal notation. Different notation to do this exact same thing in JavaScript. So when we do this inventory list dot inventory date, you can see when I add the dot syntax and I say this is a new date, suddenly inventory date becomes a property of the inventory list. That's interesting. So that's how we access. We use the dot accessor method to access properties and methods. Here's an example of an object. So performance tickets, we have an open curly brace and a closed curly brace. By the way, this is the most common way of declaring objects in JavaScript, right? You'll see this a lot. And you have it looks very similar to JSON, huh? Right? Because JSON, JavaScript object notation looks like this, right? It has a name, a friendly name for the object. Here's the object, right? Here's the friendly name. And then we have a bunch of properties. Property, customer name, and here's the value. Property, performance, another property name, performance name, here's the value. And it's separated by commas, all right? Here's the ticket quantity. Here's also another value. These values are strings, right? These values are, no, this number is a number, and this is a date because it's a date object. Performance date is a date object, okay? So that's how it goes. Performance, customer name, performance name. This is the performance tickets object. And performance tickets object has 1, 2, 3, 4 properties. Okay? When I want to access the customer name, I have to say performance tickets dot customer name. That's how I access it. If I want to set it or get it. If I want to set a value, I say performance tickets dot customer name equals. If I want to get a value, I can say console.log performance tickets dot customer name, and it'll print the value. It'll get the value from the object, right? Here I'm defining values. Let's keep going. So in that way, I can have something like this. Here's something more complex. I have an order, and the order has a property called order number, some weird number, right? Actually, it's a string. And then inside the order number, I have another object, right? This is allowable. And this is what causes confusion. Because now you see one object nested inside of another object. And you're like, oh my God, what the hell is this? Right? How do I access these objects? Well, actually, it's like this. Order.address.street. Right? That's how you get to the street level of the address object. Order.address.street. Order.order number. order.address.state, right? So this is the inner object. This is the outer object. Okay? Are we good still? Are we good? We're going to build. This is where it gets difficult, and it gets a little bit confusing. We're going to talk about this week and next week. That's why I'm bringing it up now. Right. Associative array. It's like a regular array, except it can have an alphanumeric key instead of an index. Okay? Here are some examples. Here's stoplight colors. Stoplight colors. Stop is red, caution is yellow, go is green. Stop, caution, and go are actual properties. So you would access them like stoplight colors.stop, stoplight colors.caution, stoplight colors.go. All right. Well, we can also use an associative array like this to say stoplight colors. Instead of using the dot accessor method, we can use the square brackets and put the name of the property in quotations. Not a very common way of doing things and not recommended, but you may see it all kinds of places. By the way, in PHP, you see this kind of associative array with key value pairs everywhere. For example, the session variable, all kinds of other stuff you'll see in PHP, it's stored like this in an associative array. So this is just a way of accessing the values inside this object. Just another way, instead of doing the object name dot and the property name. Okay? Are we clear so far? Let's continue to build. Here's my order. Item 1, price 1, item 2, right? Price 2, item 3, price 3. And you can see that there's several items and prices inside of my order, right? My order has several of them. Okay, that makes no sense though. Wouldn't it be better if each of the orders had their own object associated with them? So it'd be an object of objects. Sorry, I know I'm going to confuse you here. Here's how you would access that, an item list, right? So get element by item list, inner HTML is plus equals to, I'm going to get my item, and then my order, item plus I. And notice what I'm doing here is I'm actually using associative arrays. Here's an associative array to access the order object right here, right? And to look at the item plus I in the loop to indicate which item you're looking at. Not a great way of doing things, and I don't recommend it. It's enough to make your brain swell, right? Well, okay, this is another crazy one. Okay, current total items is plus equal to 1. Okay, we're increasing total items. I'm getting my item name dot inner HTML, whatever that is. All right, current price, I'm getting my item price, inner HTML. Cool. I'm getting my, let me break this out for you so you guys can see it better. There we go. And my new item property name is item plus my total items, and this would be example item 4, right? So I've got my total items. Every time I have the number of items, I add 1, right? And you could totally do it this way, but it would be really ugly. And notice how I'm accessing it with my dot accessor method. I'm using order dot new item property name is equal to current item, right? Where a new property, new item property name is I'm collecting the item itself, whatever it is. So different ways of accessing the objects. We're not going to do it this way very often. It's confusing for most of us, right? And it's not recommended. This is the good way of doing it for sure. Order.price, order.new property, and so on. It's just this kind of stuff where you construct the object on the other side. That can be very confusing. All right, I want to make a method. So we've talked about objects, but I want to add a method to the object. Here's a great example. I want to create an object. Before we go on, I want to create an object, right? My object is going to have 2 points, X and Y, all right? Or two coordinates, X and Y, okay? I want to call my object point 1 and my other object point 2. If I go back to my list, if I do the similar example here, instead of doing it this way, I could have done it like this. I'm going to reconstruct this, okay? So bear with me. I could do something like this. Let point 1 equal to Here's my object notation, right? And I could say something like this. X1, that's the object, that's the property, is equal to 10. And Y1, actually, let's just make it Y. We don't have to do Y1 anymore, right? I can make it Y is equal to 10, right? So this is 0.1. Let's get rid of this. And let's make 0.2. I'm going to have to restructure this in a second. Let's make 0.2, right, equal to 20. Notice how it becomes a little cleaner when we do this. So I don't have to use Y1 and Y2, okay? 0.1 and 0.2, I have no choice there, but Y1 and Y1, Y2, X1, X2, you know, all that kind of stuff I don't have to do, right? Okay, cool. That looks okay. How do I use it over here? Well, it's the exact same, except for it's going to be a little longer, right? How does it look? My distance is equal to math.power x2 would be 0.2x. So 0.2.x, right? Minus 0.1.x, right? And then 0.2.y, and then 0.1.y. And why am I having a problem? Oh, I forgot. I took a bracket away. Yeah. Same thing, except I'm using 2 points. Do I get the same answer? Let's see. So I go back and yes. Oh, whoa. What's this? Not a number. How come I'm getting not a number? Well, 0.1.x, right? Oh, that's no good. 0.2.y minus 0.1.y, right? And to the power of 2. I think I messed up somewhere. Hold on a second. Math.power. Oh, yeah, I did, for sure. This should be brackets here and not here. There we go. Okay, so makes sense. Same thing. I'm using 2 points, but see how more descriptive this is? Sure, x1 and x2 are descriptive too, but this is good. So these are 2 objects, right? And what about if I print the object out? How does that look? So if I print the object, if I put console.log, and let's put in 0.1, right? We'll use the old way before we use backtick, right? And then plus 0.1. What do we get here when we do this, right? And console.log, oh, right? And then we say 0.2. What are we getting here when we get 0.1 and 0.2? We get 2 objects, right? 0.1 and 0.2 are these things, right? But these things don't have a value, yeah? Let's see. Well, yeah, they do. Look, it says 0.1 and 0.2, and they're objects. That's what you get on the console here. Object, right? Okay. Let's try something else. Notice that I said 0.2.x. I used the dot accessor method. But here, instead of 0.2.x, I want to get the access to 0.1x. What is that, right? Well, I can actually do something like this. 0.1, and then in quotations, x. That is equivalent to doing 0.1.x. Both of these do the same thing. Okay. By the way, associative array is not always available in all languages. Definitely in JavaScript and some others, right? But not all languages give you this property, right? And it's kind of weird, and people hate it. Just letting you know, right? And some people love it. Notice that they're both 10, right? Even though one way you're getting it this way, And the other one, you're getting actually to it this way. Okay. Questions so far? Have I killed you yet? It's coming. The big killing is coming, right? I don't want to, but it's when it gets more complex, it becomes more difficult to understand. All right, here's a method. So I want to create a method, and notice I have an outer object. Here's my outer object right here, and then I have a method inside of the object. So I still have. There's actually a bunch of things going on here. One is I have a nested empty object called items, and I have a method where I have the name of the method, the friendly name, followed by an anonymous function right here. The reason why this is a method and it's not a function anymore is because it's a function that's inside of an object. If a function is inside of an object, we call it a method. Okay, it doesn't matter whether we're doing it for higher level languages like C# and Java and JavaScript, or whether we're doing it for low level languages like C++ or C, right? It's still considered a method. Okay, mostly in C++. C doesn't really have object orientation. All right, so that's what it looks like. The general idea, general form, okay? And let's see if I can actually show you a better example. I don't know what happened there. So here's my function, process order, right? I can also point to a function that's outside of my object like this. So I define my name function out here, and I point to it. Notice that I'm not using the open brackets, close bracket, just like I did before. This is just a reference to this function. So I could do it this way too. So it's referencing an existing function that's not inside of my object. Okay, are we blown away yet? It's going to get crazy. This is the first part, right? So here's a method, and I'm using comma separated to kind of specify the method itself. All right, so let's try this out before we get into the next part. So I want a method that's part of my object, right? And I want to access it. I want to calculate something, right? So I want to, have some kind of function to calculate something else, like for example, distance, right? And how about, is there a way of, I'm talking about objects. We're building up the whole idea of objects, okay? So my method inside of my points, as an example, right, could do something to my x and y. For example, if I want to reset, right, I can reset my point 1 or point 2, or another way of looking at it is I could normalizing making it 1 and 1. I can make it 0, or I can make it normal. Let's try this out. So I'm going to add a new method. Here's my first method, right? I'm going to call this normalize. Right? My normalize method is a function, right? And I'm also going to have a reset method. Let's call it 0, or maybe we'll call it, reset. Reset method, which is also a function. My reset method, right, in this object, by the way, this object doesn't have these two methods, just this object, right? My normalize method says that x, right? Well, which x am I talking about? I want to talk about the object, the x that's in part of this object. Uh-oh, here we go again with the this keyword. I need to use the keyword this. This dot x. This dot x is equal to 1, right? And this dot y is also equal to 1. That's normalization, right? Set both values to 1. Okay, let's make it so that the reset resets it to 0. And maybe we, instead of calling it reset, let's call it 0, right? So we'll say this dot x is equal to 0, and this dot y is equal to 0. There's some really cool functions here, right? Because if I want to normalize or reset something, I can do that. Hey, what about taking these two functions here and using the exact same methods here? I'll just include them in my other point. Oh man, I'm duplicating. And whenever I'm duplicating, there's an opportunity for me not to duplicate, for me to create, I'm creating a pattern, right? See the pattern? They look exactly the same, these two objects. Hence, what about if I had a blueprint? A way of creating a blueprint for my methods or my objects that I could instantiate new objects of these two things, right? I swear I could, right? All right, we're not there yet, but we'll get there. All right, so I've got these two objects, and if I want to call normalize on point 2, right? I could, before I do my calculation, right? Let's say I'm normalizing point 1, okay? So I can do something like this. I can say point 1 dot normalize, right? And I'm calling that normalize function. So what's that going to do? It's going to change my x and y coordinate of point 1 to 1s. So now it's going to be a longer distance. It's going to go from 1, 1 to 20, 20, right? So it means it's not going to be 14 distance anymore. And to see that, you can see that the distance now is 26, right? Because my point 1 is 1, 1, right? Are you confused yet? I'm not trying to confuse you. But now I've created an object. This is the object out here, right? With two methods. But now notice that I'm using the exact same methods twice. And this is where I might want to create two functions that come out here. Here's function. And then I'll call this normalize. Bear with me for a second. So we'll call it normalize. And where I will do something like this. Oops. A normalize function, and then we'll do the same thing for my 0 function, where I want to take these values and copy them or cut them, put them in here. And maybe what I want to do, instead of using this x and this y, I just want to say x and y, right? Right? I want to say x, well, x, but what are x and y's? Where are they coming from, these x's and y's? If I want to zero out, right? I want to pass in an x and y value to each of these things. So I could do something like, well, there's x and y, right? Passing in x and y. And you know what? These things are 0, and I want to return x and y. I want to be able to do that x and y stuff out, right? I pass in x and y, it becomes 0, and I want to pass them back out again. How do I do that? Is there a way of me accessing, pointing to this function up here and modifying my objects? And the answer is, well, yes and no. Not really, because of the scope, right? If I was to define these two functions, x and y, first of all, there is no x and y. I'm defining them up here. This is local scope. And if I hover over, it tells you parameter x, any, right? But I'm not passing them back out, right? It's hard for me to pass them back out, x and y, right? I could return them. But I can only return one object, one thing. I could do something like this, return, and I could return an object where x is equal to 1, right? I could do this, right? So I don't have to do this at all. I could just say, well, x is equal to 1, and I don't have to even pass it in, right? Nothing, I don't have to pass anything else in here at all. I could do it this way as well, right? So x is equal to 1. Bear with me while I do this. This is a different kind of function. And y is equal to 1, right? I could do that. And I could do the 0 function the same way, so I don't need x and y's in there. Bear with me while I redo this. And then return an object that has x as 0 and y as 0, right? I could do that. But this would be different than what I'm doing here, right? And I have to pass it in somehow. I have to call that function somehow, right? So when I normalize, right, what I'm actually doing is I'm saying, whenever I call the normalize function, I'm actually calling normalize with a capital N, and I'm returning this dot x, whatever the value is of x is equal to x. So an example of that would be, it would be more complicated than this, right? So that won't really work if I did this, because of the scope, right? Because now this function returns two numbers, x and y, right? But it returns 1 and 1. That's what it's really returning, 1 and 1, right? I could do something like this down here. I could say 0.1, right, is equal to normalize. I could do that, right? But now, well, we got a bit of an issue, right? It accepts 0.1 accepts a value, and I'm returning a value too, but they're incompatible. What happens here? Is that possible? And if you look and see, I still get the same number, right? But now 0.1, because I've overwritten it with normalize, which is a function, this function right here, and the function itself returns, sorry, the function itself, this one here, returns an object. This is what it's returning, but it wipes out the normalize and 0 methods because I'm overwriting what the thing is about. It's not adding on to. Whoa. Okay. Is there another way to do this? And there is. There's another way to write this whole thing too. And I'm going to show you this without going through the PowerPoint in a second. Okay, so this is a nice idea, Tom, but that's not going to work. And this is a nice idea, Tom, but that's not going to work. What if I had an object called point object, right? And point would be like a function. So let's say something like function point. Right, here's my point function, right? And my point function has 2 objects. I can have this dot x, right? And I also have, and maybe that's going to be equal to, there's going to take 2 parameters, x and y, right? Where this dot x is equal to x, and this dot y is equal to y. Okay. Look familiar? And what I want to do here is this object, right? And I can say this dot normalize, right, is equal to an anonymous function. I can do it this way as well, right? Where I can say this dot x is equal to 1, and this dot y is equal to 1, and this dot 0 is equal to a function where this dot x is equal to 0, and this dot y is also equal to 0. And why is that going to be an issue? I didn't spell function properly. There we go. Okay, so this is a point, right? But it looks like a function. But it has 2 functions inside of it, right? One function here and another function there. These 2 things are methods because these methods are inside of another function. And this looks like a point. Okay, I like it, right? But I can't really call normalize, right? Because normalize is point.normalize, but it's not really. It's normalize available outside of point. Is it? Let's try it. So if I say something like console.log, right, point.normalize. How come it's not coming up? It's not coming up at all, right? In fact, if I do something like this up here before the other things come up, I'll get an undefined or something, right? Yeah, right? And the reason why is because these points here, normalize and 0, right? These 2 things aren't really part of point, right? Point itself is just a function. These 2 things are functions within the function. I can call these 2 private functions. That's what they are. They're encapsulated inside of this other one from within the function, right? But that's all I can do. How about this x and this y? Can I call those? Can I do something like, point, let's go do something like this. Point x is 10 and 10, and then I want to kind of, I don't know, I want to look at the x. Can I do that? Can't do that, right? Because there is no way of accessing that stuff, right? I can't just sit there and go, okay, set this up like this. So in fact, I'm almost setting up something like a class, right? Here's the constructor, right? It's almost like that, my point class, my point function. And it would mostly look like this. Let's say, for example, I kind of close this up here like this, here's my constructor. And if I wanted to add normalize and 0 as methods of this object, I could do something like this. By the way, please bear with me while I do this. This dot prototype, and again, prototype, come on, Tom. Prototype, right? This dot prototype dot, and then normalize, right? And by the way, it's not this, it would be point dot prototype dot normalize and point dot prototype dot 0 is equal to function. Now can I call them? Well, let's see. If I was to go in here and go something like return point dot normalize, well, it's still not really coming out, right? Can't really do this, right? Because this doesn't really exist, right? If I kind of do this again, I go back out here, still get this error, right? What if I do something like this? Let my point is equal to a new point, and I pass in 2 values, 30, 30, right? Can I do that? Then can I go my point dot normalize? Will I be able to do that? And the answer is, well, kind of. Almost there. Are you with me? I know we're going crazy, right? Yeah, but my point dot normalize calls something, right? So I could do something like my point dot normalize. I could do that. And then I could call my point dot x, right? Let's see, can I access x? I can, right? And then here's my point. I'll say my point x. And then here is my point y. Will this work? Do you think this will work? Here's point prototype. Notice I use the word prototype. Prototype basically says this. It says, hey, take your point object and add on this normalize function, right? So here's an anonymous function, right? And I'm making this anonymous function. This is going to be, this normalize name, friendly name, is going to be the friendly name for the function that basically sets x and y to 0 to 1, right? And the same thing goes with this. And I'm using the point to start it off because I'm saying, hey, take my existing point function and add something to it with the prototype key, the keyword. Okay, if this is cool, if I can do this, and I can do this, let my point is equal to new point 30, 30, right? Then, theoretically, I should have x and y be 30, 30, right? When I come down to it. Do I console log it? My point x, my point y? Did I save it? Or is it not printing? 10,000, my point, oh, here. So my point x, my point y is y, right? But why is it y? Because I'm normalizing. I normalize everything. If I don't normalize, if I do this, and you can see it's worth 30, 30, right? Okay, cool. So this is how we can make classes and objects, right, in JavaScript. Look, I've just done a, this is one part of the class. This is the constructor, right? And here's another part of the class. This is my method, normalize, and this is another method, 0. Notice that they're separate pieces, right? Is there a way of making this all one? We'll sit there and think about this for a second. Okay. First of all, let's create objects of this type of thing. So I'm going to get rid of this for a second. And now that I have this point class, that's what it is. This is like my point class. So this is like a point class. Right? And this is like, and I'll say this is like a point normalize method, right? Or the normalize method. That's what it is, right? By the way, we'll make it so it's capital N for methods, right? And capital Z or Z for 0, right? And this is like, I'll say it's like because it's not really yet. This is like a 0 method. That's what this does, right? And this is not just a class, but a constructor. That's what it is, right? The constructor method. Okay, well, where's the kind of overriding class? Well, what about if I try to do this here? So instead of .1010 and do all this work, could I define this differently, point 1 for point 1 and point 2? And the answer is yes, I could do something like this. I could say, let point 1 equal to a new point where I pass in 1010. I could do that, yeah? And I can get rid of all this. And that's the first point. I'm building you up to make you crazy here, right? But here's the next one. I could do let point 2 equal to a new point, right, which is 2020. Now, we should still get the distance being 14 dot something. We don't need this anymore. Does this make sense to you? So here's our original prototype. This is our point function. I'm using the this keyword for that, right? And then I'm using prototypes to assign different functions to this function. So functions within function. These are methods, right? And then I'm using the new keyword to create 2 new points based on the original point function. Point class, point constructor. Let's try this out and see what I get. Yeah? See? By the way, this other stuff here is just calculating the first die and second die, right? Now, this can be very confusing, right? Because it's not notation that you're used to, especially prototype. The keyword prototype is like, what the hell is that, right? Don't be afraid of it. It's just a way of adding something, adding a method or a property to another object. Okay? Let's go back to the PowerPoint to end this off. All right, so they're talking about custom properties here. And what you can do is you can enumerate custom properties by using the for in, by basically going through one property at a time. This is neat, but again, what you're doing here is you're saying whatever the property is, you basically iterate through each of the properties and then print it out. Okay, that's what this is doing. The delete operator destroys a property, gets rid of a property. That's what the delete operator does. For example, order items in stock. It'll just destroy the items in stock property. It won't exist anymore, right? This is where I went. I went with the constructor function. The constructor function, basically what it does is it creates this custom object, right? Now, constructor notation looks something like this, exactly what I did. I used the this keyword to establish values for these parameters. So these parameters come in, and then I use the this keyword to describe my properties. These are what we call class properties because we're using the this keyword. And then we're assigning the value that's incoming from the parameter that's going into the constructor. Okay? Now these properties are part of the order constructor, we say, or the order object. And I can do the same thing with methods. Now the methods are a little weird. Here's my display order info method, right? And it's, yeah, this is nice, and it's kind of crazy that I want to do this big thing here. This is this display order info. It'd be nice if I can add this method into the order function itself. And the way we do that, of course, is with our prototype property, which is what I just showed you, right? Let's take a look at this prototype property and see what it looks like, right? So now it doesn't really show you the details here. One great place to see this, and I'm going to show you TypeScript at the end of this session, when we're together at the end of this semester, I'm going to show you something called TypeScript, which actually makes building classes for JavaScript easier. Let me show you this now, so you have a blueprint of how this works. You can go to a playground called typescript.org, typescriptlang.org. Please go there. TypeScript is a superset of JavaScript. It allows us to write things with constructors And it looks very similar. If I go to playground for a second, here is something of a playground for you to see. All right, so I've got a person interface. Let's get rid of this here. Let me make a new one. Okay, so here's my interface. I want to have a class. Here's my class. My class is going to be the point class. Okay, take a look on the right. My right is what my pure JavaScript is. So here's my point class. I want to take a number, x, right, which is a number, and y, which is also a number. And inside my class, my point class, this is my constructor, right? I want to actually do this down here. So I want to, my point class itself is just a container, right? Typically, it looks like this, point class, right? And then I have a constructor. I can actually type constructor. My constructor takes x as a number and y as a number, right? And then what I can do is I can set up some values. I can say, well, x is a number and y is a number. Right? This looks like what you might see in Java or in or C#, but with the constructor keyword instead of the same name as the function. So this is my constructor, right? And these are my properties, right? Properties. Okay. And let's say I want to say something like this. This dot x is equal to x, and this dot y is equal to y, right? That means the x and y values that are coming into the parameter, into my constructor, are being assigned to the properties that are inside my class. Yeah? Look at what I get over here. Huh. Now you're looking at it and going, what the heck is that, right? But this here is classic JavaScript, okay? Classic meaning ECMAScript 5 and before, right? And if you notice, this makes more sense to us when we make a class called point, right? Well, actually, what we're really doing is we're creating something called, we're using an iffy. Look, there's the iffy right here. Here's the iffy. We've seen the iffy before, right? Inside of there is a constructor function, and we're returning point. Notice that the point constructor function is called the same name as the class in this case. Does this make sense to you? Okay. Now if I establish a new point, I could do something like this. Let my point is equal to new point, where if I pass in a value of 10, 10, right? Notice what it looks like on the side. Exactly what I did earlier, right? Notice it changed the lets to vars because it wants to make it backwards compatible. This is TypeScript, my friends. And once we use TypeScript, we have the power of classes in our hand. It didn't break. We have the power of classes in our hands. We can use the same object-oriented methodologies that we know in Java, in C# and in other languages, and we can harness that to build more complex objects in JavaScript. Okay, let's keep going with this. If I want to add a method, here's some methods, right? I can do that. I can do the normalize method, right? Which, by the way, returns void. And the normalize method does a couple of things. It says that this dot x is equal to 1, and this dot y is equal to 1. Notice what's happening over here, right? Exactly what I did. And I can also do the same thing with my zero method. My zero method, which returns void, is this dot x is equal to 0, and this dot y is equal to 0. Notice that, oops. Notice that on the right here, this is what I'm doing. Now, did I do anything different when I wrote my functions? I actually did the exact same thing, yeah? The only difference is this. This is the beautiful thing, right? And why do I write my iffy? I've been doing it with you the entire time, right? We have an iffy surrounding my code right here. Take a look. Look, this is the iffy right here. It's been surrounding my code the whole time. It's a closure. That's what it's called. And that's what finishes off our class, okay? So in order for us to finish off our class, we're going to get back to this again next week. Don't worry. We're not going to just touch it one time and then see you later, right? So if I go back to this, what I need to do to finish off my class example is, this is like a constructor. Now it's going to be a constructor. I need to do something like this. Let point, right, be equal to an anonymous self-executing function. Remember this notation? Yeah? Make sense? Look what it shows here. An anonymous self-executing function, right? And then I'm going to take all this stuff, copy it or cut it, and put it inside there. That's part 2. So part 1, you make an iffy, and you make a name for it. Part 2, you put in your constructor. Now this is a constructor, not like a anymore. And this is a normalized method. And here's the 0 method. And now the only thing that's missing is our return statement. Without our return, we're not returning the constructor. And without returning the constructor, because we're adding normalize and 0 to it, right? Without returning the constructor, we cannot use the new keyword. Now, there's no difference here when we use it. The difference is that now this is encapsulated into one object that we're returning right here. And the only thing that's available outside of this object is point. What if I wanted to make my X and my Y available, right? Again, if I was going to check it out here in the playground, I could make this public, right? I could make this public, right? So I could use the public keyword here, right? So I make public X and Y. Notice I'm still using point here, right? Public X and Y. Now, no difference on this side. So I can use whatever I want over here. But on this side, there's no difference. Point. Right? How about if I want to make it private? So I said private. Oh, now we're getting into some differences. So private X and Y, well, no, it's exactly the same, right? Even though I like to think that there's private and public in JavaScript, there isn't. It's just for us for code hinting in the end, right? Anyone have any questions around objects? Now, I've used this TypeScript playground as an example, and I want you to always think about it. If I ever ask you in an exam, right, to create an object, which I will, it's going to come at the final exam, right? Create an object. I'm going to tell you to create an object. This is perfectly okay. You know, if you know how to create an object with TypeScript, then it will just translate nicely like this to JavaScript. This is the JavaScript side. This is the TypeScript side. Okay? The only difference between TypeScript and JavaScript that you can see is you can add a type to the properties. Notice I don't have to use the let keyword in here, or var, right? And notice over here that I use my constructor keyword to indicate what the constructor is. This is the constructor function. So instead of having the same name, point, I just use constructor. By the way, if you learn TypeScript, which you will by the end of semester, you'll have a little bit of an idea of how TypeScript works. You would have learned the beginnings of ECMAScript 2015, which is the most modern way of doing JavaScript. Questions? Okay, I think I've overdone it with you guys today. I think you guys are going to have a brain ache when you go home, right? But I want you to think about this, because once we are able to create objects, right, like this, our point object, then I can do a lot of wonderful things with it, like add on other functions, like the distance function. Right now we haven't added in, but there's a way of adding in my distance function so I can calculate the distance between 2 points. I already have a point. I can calculate the distance between 2 points by asking for it to have 2 points, right? So I take point 1 and point 2, and I can get the distance between point 1 and point 2. I can make it a static method. I can have static methods, and I can have methods that are not static, right? And I can include my static method inside of my point class. Preview. So I can go down here and go, all right, public static, right? And my method's going to be called distance, where I need a point, right? And my point 1, which is a point, and P2, which is a point. Okay, notice that I'm using the point keyword, right? But point is this class, right? And then what I can do is I can take that same calculation, right? Which is this. Right? This right here. I can return this whole thing here. And I'm going to return a number, of course. And we're going to say it's P1, P1.x, and this is, so it's P2.x, P2.x, and this is P1.x, 1.x, and this is P2, P2.y, and then this is P1.y. And now we have a distance method that's part of the point class that's also public static. And if you look what it did this. Make sense? So it's a little different. We're going to get to this later on, but this is like a static. Notice it's not a prototype. It's not a prototype, right? If it's not a prototype, it exists in all classes, right? This is a property. That's what I've done here. A property that has this value, that kind of returns this value, right? So with this, if I was to take this exact thing here, exactly the same. I'm going to copy it from here and put it, hold on, and put it inside. Are you tired or is that a question?
Yes.
Tell me.
Dumb question. What's a prototype?
Prototype is like I'm adding on to the original blueprint, the original object. I have a point that I create, my function point. I want to, with the prototype keyword, I just add on, I'm attaching. Think about me attaching with the prototype keyword. It allows me to attach something else to it.
It's like a new object without a class that created it.
Correct. Yeah. So notice now that instead of doing this, let distance is equal to this, I can just go, I want to return, so distance will be equal to point dot distance, and then I can pass in theoretically 0.1 and 0.2. Right? That's what I want to do. That's the preview. Notice the distance is here, point distance. And if I go back though, we get this, right? So even though I don't have to do that whole thing, I can include it in every one of the points. The points, a class itself has as a static method. This is a static method, right? That's accessible from all points. Are you guys confused yet? I can keep going. No, I'm not going to keep going. Guys, thank you so much. We'll see you next time. I know we ran over a little bit, but this is the beginning of our journey with object-oriented programming in JavaScript. All right, take care. See you next week. I'll put this up on GitHub.